So we will be starting this sequential circuit. So I will be making an introduction. So our class is related to this digital circuits, right? So we are learning about these digital circuits, and at the beginning of the course we said we have two different digital circuits. One is combinational circuits and another one is called sequential. So in this type we have seen adders, comparators, encoders, decoders, muxes, demuxes, right, etc. So in these cases, output only depends on combination of inputs. But in the sequential case, the output depends on the state. So we have some state and then the output depends on this state. So when you say state, so our circuit needs to have some kind of memory. It needs to remember, okay? So we need to remember our state, and based on this state and inputs we will be changing our states, okay? And then we have some input, so together our state and inputs we will be having a new state. We will be going to new state, okay? So in the sequential circuits, what we will be seeing, latches. So these memory elements are latches, flip-flops, and static RAMs, SRAMs, and dynamic RAMs, okay? So we can have these memory elements, right? A simple memory element such as latches and flip-flops. So we can have some memory elements so that we can remember our state, and then based on this state we can evaluate our next state. So basically we will also learning about finite state machines. These are examples of sequential circuits. A simple finite state machine is, for example, a counter, okay? So in the counter, for example, you have a state. Let's say you are starting from state 0, then you increase it, you become state 1, then state 2, 3, 4, etc., right? So you are counting. So you are changing your states. But while you are changing your states, what you are doing? You are remembering the current state, and then after that, based on some inputs, right? Maybe your input is in the counter is at some time, right? After some time, you are switching to another state, and then you are increasing your states and you are counting toward upwards, right? So basically in the sequential circuits, what we are doing, we are periodically doing some operation. So this could be like executing an operation, such as this could be add operation, this could be subtract operation, this could be a multiply operation or a division operation, right? It could be a comparison, right? Or whatever. So we could be doing some increasing our counter, for example. Or I might be reading or writing a memory location, or I need to change my state, okay? Or I need to read my sensor, right? But I need to do all of these with some time intervals. So, and I do it periodically, right? For example, a microprocessor in your computer, right? It has a clock and it's doing these operations. It's doing some addition, subtraction, multiplication, whatever it needs to do. But it needs to do it periodically. So if you say periodically, what we need is, we need a clock signal, right? The clock signal tell us the period of this operations. So how often we perform our operations, right? So what is the speed of my counter, for example? How fast I am counting, right? So we do this periodically count it, but a signal needs to tell us how often I do it. Or it can also tell us our bit duration during data transfer, right? So I am transferring some data, but what is the duration of my 0? What is the duration of my 1? So this is what we have in these sequential circuits, right? Now you can tell these combinational circuits, they have no clocks. It does not have any state, right? So it only looks at the inputs and then it determines your output, but it does not remember past values. So you give an adder an input, let's say 0 and 1, it will give you a 1. Next time you give it another input, then it will give you another output. But it doesn't remember what was the previous output, right? But the counter, for example, let's say I have an enable input for the counter. Anytime I enable, I increase my counter by 1. right? It needs to remember its current state so that it will estimate the next state. So the sequential circuits depends on the both current state and it has some inputs and it will give me my out. But the combinational circuits, I have some inputs and it will give me some output, right? So this is the major difference between this combinational and sequential circuit. So we said we need a clock signal, right? So we need this clock signal with some period, right? So in this case, this clock signal is oscillator, right? It is oscillating between 1 and 0. Let's say I have 1 here, 0 here, 1, 0. So it's always doing this behavior. It is 1, then it's 0, 1 and 0. So, and this is the period of my signal, right? We call this T and this is my period. So it is always repeating this 1, 0 behavior. So this is my period. You can also measure it from here to here. It doesn't matter. It will give you the same thing, right? So this is called duration of one clock cycle. And then we have a frequency of this clock, right? My frequency is defined by 1 over T. Okay, so if my clock is 1 gigahertz clock, right, then it means 1 over 10 to the 9. Then my clock period is 10 to the minus 9 second or 1 nanosecond. So it means this is 1 nanosecond and during 0.1 nanosecond, right, so this is 0.1 nanosecond, my clock is 0 and the remaining 0.1 nanosecond my clock is 1. So this is repeating, so it is toggling in a way every half nanosecond. So the clock repeat itself every 1 nanosecond, which is our period. So it is toggling every half nanosecond. So also we said our clock determines our bit duration, right? Let's say I have in my transmitter, I need to send some bits, right? I am sending some signals like this. So at the receiver, I got the same signal. The transmitter, I know what I am sending. But at the receiver, what is this signal? Did I send 0, 1, 0, 0, 1, 0? Or did I send 0, 0, 0, 1, 1, 1? 0, 0, 0, 0, 0, 0, 1, 1, 1, 0, 0, 0. So if I don't know the duration of my bit, this could be many things, right? If my frequency is very high, for example, I could have many zeros here and many ones here and many zeros here, right? So I need to determine my bit duration so that I will also tell the receiver, okay, so this is my clock, for example. So if this is my clock, then, so this will be my bit duration, right? So this will be, for example, a 0, another 0 here, and 1 here, a 1 here, 0 here, 0 here, 0 here. You got the idea, right? So by learning about my clock, I can tell what is my bit duration, and using this clock period, I can also determine if I send 0 or 1. Okay, but currently this is the basic introduction to the sequential circuits. One main application of this, as I said, is a finite state machines, right? So let's say I have an adder here and I have some kind of memory here. So I will be keeping my present state here within this memory. And then let's say this is 1. So this might be my clock signal. Let's say this clock is 1 nanosecond period. So every 1 nanosecond, I am adding 1 to my present state. And I will be changing my present state. Let's say initially my present state is, let's say this is a 4-bit memory and I have adding 1, so I am adding 001 here. Okay, so let's say initially my present state is all 0, right? So initially this is 0000. So I am adding 000 to 001, so I will getting a 1. The next state will be 001, but in 1 nanosecond later my present state will change to 0001, right? Now instead of this 0000, we will have 001 here, and this is after 1 nanosecond. Then I will be adding this 001 with 0001, so I will be having a 2 here. So this will be actually presenting my next state here. Okay, so my next state will be 0010, and then 1 nanosecond later, I will capture this 2 into my present state. So now my present state will be 0010, and then I will be adding 0010 here, and instead of 2 now I have 0011. After 1 nanosecond I will be capturing 0011 here, so it will continue like this. So this is like an counter, right? So for the counter I need an adder, and I need some kind of memory and a clock signal to change my states every clock cycle.